Hey guys, welcome back to AlgoYogi. We are doing tree series right now. Our next problem in the list is find bottom left tree value. Let's visit the problem on LeetCode. The description is one-liner, quite really simple. Given the root of a binary tree, return the leftmost value in the last row of the tree. So you can see we'll be using level order traversal, which is breadth first search, and once we reach the last level, we just need to return the firstmost value or the leftmost value of our last level. We can't really do the DFS. Some of you might be thinking we could do why not in order traversal and return the first value, because it might be the case that our leftmost value, the leftmost value of my tree, might not be the leftmost value of the last level, because the example 2 depicts that, right? You can see that. So in order to solve this problem, we will use BFS, as I already said, and as we are going to use Q, what we're going to do is we're going to have a variable called last left, and that will store the first value of the queue, small q, and small q will be basically a snapshot of our main queue. And when we are visiting all the children of all the nodes inside my small queue, we will basically append those children to be processed in the next level in my main queue. So I think the answer is going to be quite really simple. So I don't think we really need to do anything over here. It's quite really simple problems. Just we can see the second example though. Here our main queue will contain node first, which is the root node, and then we'll pop it out, and we'll start basically, we pop it out, assign it into our smaller queue, and then we from small queue we pop it out and we process this, and also we update this to our variable here, right? That's what we said. So my last left would be 1. See, the reason I'm doing it here like this, so that currently I do not know how many levels are, but we are going to do it at each level, so it will be updated even at the last level, and that will assign it the first value, and that will be our answer. So let's write down our solution and get it done. It's an easy problem. We have done so many problems of trees. Now the solution is just right there. So I guess since I'm doing it for enjoyment, I'm not really gonna go over the same concept again and again. My purpose here is to solve these problems and motivate you guys. You guys can study with me, you guys can solve the problems with me, and also make use of AlgoYogi, and yeah, voila, inshallah you'll be successful. All right, okay, let's write our solution. So I'm going to have a main queue that is going to, and they said in the constraint like there will be at least one node, so let's assign it root. Then I'm gonna say last left for my answer. Initially let's just call it -1, and then, or let us call it root dot value. There will be at least one root. So while q smaller q takes all the values of q, so that we are visiting one level at a time, and then I will assign my last left the first value of q. So since we are returning an integer, so let's just take the value of it, because it will be a node, right? We are storing nodes into our queue, like we stored root here. Then what we are going to do is we are going to iterate over for node in queue, node in queue if node dot left, then we can assign it, we can append it to my main queue since it goes into the next level, right? And it will happen for the current all the nodes in my current level. So queue dot left, queue dot append node dot left, and same thing we are going to do with our right child. All right, and that's it. Our answer is right there. We can just return last left. Okay, let's zoom out, try to submit, and yes, so this queue needs to become empty, right? Because we're getting rid of one level. Next time it will be the next level we will be processing. So now I guess it should definitely pass, since our logic is absolutely correct, and that's pretty efficient. Let's write down the time complexity. You guys already know it. Okay, which is big of n, visiting each node at a time. All the nodes, basically, that's what I meant, node at a time. Of course we're visiting each node at a time, but one node one time. And space complexity is going to be basically, in this case what's happening is we're not storing nodes more than on one level, but there could be one node and one length of that level would be 1. So we're gonna just say it n for best case, worst case, whatsoever. But okay, let's go back to AlgoYogi, mark this problem solved, and see you guys in the next problem. Until that, bye bye.